Alright, this is a wrap-up section on Chapter 12.8, which is the probability of compound events. Because you've already done probability, I'm not really going to get into that, just knowing that it is success over total, as we learned in our last part. We are now going to do compound events, which means either we're going to make multiple selections or we're going to deal with a different type of selection. So again, there are two types of compound events. There is and there is or. Because of the direct nature of this lesson, I'm just going to go ahead and separate this into two sections, do a few problems, and again give you some time to kind of practice and ask questions. Other than that, remember, if you get 100% on all your homework, that you get a chance to work towards your extra credit assignments. So make sure after you finish this that you work as hard as you can. Key thing for AND is whenever you're doing multiple selections with AND, you will multiply your probabilities. And so if you had a question like this that said there's 7 red toys, 5 blue toys in the bag, you want the probability of selecting a red and then a blue toy if the first car is not replaced. Now that's important because the probability of selecting a red toy is 7, because there's 7 good picks out of total of 7 plus 5 or 12 total. So what we do is we now take that and do 7 divided by 12 and get the decimal. I'm going to go 3 decimals places, 0.583. Now the probability of selecting a blue toy, the number of successful blue toys is 5. The problem here is that you did not replace the first toy. And so yes, there were 12 total toys in the bag. I guess there's a lot of T's in that statement, but there were 12 toys in the bag. But now, because you selected, assume that you selected appropriately, but you selected the first one that was correct, there's no longer 12, there is now 11. And so now you kind of use that counting tactic of moving down one because you've already selected one. So again, if it's not replaced, you have to change it. And so now we have to do this number here, so 5 divided by 11, which is 0.455. And in the end, because you want a red and then a blue, that means you're going to take this times this, because you want both of those things to happen. So 0.583 times 0.455 gives us the probability of 0.265 as your final probability. So again, you still have to know how to do your probability work. You still have to understand what probability is about. But just remember, if you are doing 2 selections and you want both of those selections to be a certain situation, you take the probability of the first, you take the probability of the second appropriately. Remember that if they did not replace it, that would drop down 1, and you simply multiply those two things. Now if you look to the right of your question number 1, you should see question number 2, where there are 8 red toys, 9 blue toys. This time we are selecting and the first toy is replaced, and I'm doing this so you see both types, so you understand what you need to do. So again, the red here is 8 good picks out of 17. I'll adjust them in just a second. The blue is 9 good picks, and because you are replacing it, you would still have 17 toys, because if there were 17 toys in the bag and I selected one out, that would give me 16, but if I am replacing my first pick before selecting again, it goes back to 17. So I then turn both of these into decimals. That is 0.471, and this is 529. And so we now take 0.471 times 0.529, and you end up with 0.249. Alright. So again, key idea for AND, if you're making multiple selections, it could be 3 selections, 4 selections. It could be red and red. It could be anything like that. But if you are making multiple selections and you want both of those things to happen or all of those things to happen, you simply multiply the probabilities for that. That's what AND is. So a different type of AND is you have 3 red marbles, 8 white marbles, 5 blue. You choose a marble, replace it, then choose again. This is saying find the probability of choosing a red and white marble. Alright, so again, what you do here is take each part, probability of selecting red, 3 good ones out of 3, 11, 16, which I'll go ahead and convert, 0.188. And then you want a white marble. Again, the key thing is the top number is easy. There are 8 white marbles, so there are 8 good picks, but you have to remember to always go back for your second pick and ask yourself, am I putting it back? Because we are replacing it, that means that there will still be 16 marbles in there. We of course should know this is 0.5, and so we do 0.188 times 0.5, and you end up with 0.094. Alright, so again, the difference here, the first selection is your typical probability, but you have to make sure you're careful on your second probability, because if not, you're going to put the wrong number down here, and it does make a difference in your answer there. You have a bag of 7 red marbles, 4 white marbles. Again, I just try and give you different perspectives on each of these things. Here you want a red and a white, but this one says you choose again without replacing it. So again, the probability of a red here is 7 out of 7, 11, looks like 14, which in this case is 0.5. And again, you want a white marble to be chosen. There are 4 white marbles, but again, if you did not replace it, it would no longer be 14 marbles in the bag, because as soon as you select a red marble, you now have 6 plus 4 plus 3, which is 13. Again, that's where you have to be careful. That gives me 0.308. And again, because I want both of those to be true, I simply multiply them together. So 0.5 times 0.308 is 0.154. Alright, so that represents the AND parts. Again, the rest of that you just need to kind of work on and get some practice, and make sure you discuss and bring up your questions and do what you need to do. Remember again that this test is going to make a big difference for those of you who did badly on Chapter 9, because this test can actually pull your grade up a whole lot, along with the quiz that you hopefully did well on earlier. But again, putting both of those together should kind of put you in at least a decent spot. Maybe not where you want to be yet, but hopefully you understand that. I meant to read something else on the bottom of that. Whenever performing a selection based on OR, what you do is you add your probabilities. So again, AND means multiply. If you have a OR, and again it's a selection, it's not multiple selections, because whenever you're doing multiple selections you want red and white, you want black and blue. OR means you're making one selection and you've got a couple different successful options that you want to choose from. So again, OR means you simply add your options together. So in this case you have a bag of 3 red marbles, 8 white marbles, 5 blue marbles. What's the probability of selecting a red or a blue marble? So what you do here is, again, you look at your option of choosing a red marble, which is 3 out of 3, 11, 16. Or 0.188, I think I did that before. And then you also would like a blue marble. So again, red or blue. So in this case we have 5 blue marbles to choose from out of, again, because it's one selection, it's still out of 16. 0.313. And so you now take those two numbers and add them together. And you get 0.501. Now, if you look at number 6, you'll notice that it has an asterisk by it. I'm doing that because I want you to understand that there are actually 2 ways to do an OR problem. I show you this way because if the numbers are really out of control, then you definitely want to use the system here. But what you also could have done if you want a red or a blue marble is you could have looked at your number of successes, which is 3 reds and 5 blues, which makes 8 total marbles to choose from out of 16, which, as you see, is pretty much the same as that. The only reason why that's 0.501 is because we rounded both of those. But again, that probability is the same. The only difference was, again, that we rounded both of those numbers, but I almost guarantee that if you took both of those decimals and add them together, you'd get 0.5, because that is about right. Alright, so when you're looking at something like this one, I would definitely do it that way. 4 red chips and 7 white chips. You have 1, 2, 3, 4 in red. You have 5, 6, 7, 8, 9, 10, 11 in white. You want the probability that is red or odd. The best way to do this to me is not to do the probabilities, because there are things that overlap here. You'll learn more about that in your higher level of probability. So what I would do here is say I want red chips, so I have 1, 2, 3, 4 good ones so far. And I don't need to count the odds here because they're already red. So again, red or odd means I want something that's red, which works. 1 and 3 are both odd, but they're already in this selection. But I do need to add on 1, 2, 3, 4 more, which gives me a total of 8 good ones out of 4, 7, 11 chips. And 8 divided by 11 is 0.727. So again, I would not do it with this because there's so many things overlapping. Red or odd, you have 2 things that are odd inside the red, and it would get very complicated if you happen to do the probability of red plus the probability of white, or probability of odd, because it would not work since you have 2 things that are overlapped. So again, if I were you, I would just make sure that you do that the way that I just did, which is just pretty much underline everything you're looking for, red or odd. So 1, 2, 3, 4, 1, 2, 3, 4. So there's 8 total good ones, or 8 total successful choices out of 11, and that should get you where you need to be. Outside of that, go ahead and go to your Math Excel again. Please make sure you ask as many questions as you can. It is a shorter assignment. That way you can try to start working on your 100%, because your extra credit assignments start tomorrow. Other than that, good luck.